Yeah. Well, Colton did it for like a day or two. He was gone for like 2 weeks on his vacay, playing golf somewhere or hunting or something.
No, he was at Super Young. My mom saw him at Super Young, and he was sick.
He has to eat.
If you want to be baby sick, at least don't tell him something where you literally have a conversation.
And hunting is isolated.
He's hunting and going to Super Young.
He was probably hunting. All right, now. Take a look at this one right here. What do you notice about number 23 and 24 and 25? They are conjugate pairs. So when you take A plus B and you multiply it times A minus B, what do you guys get? A squared minus B squared. So what is A squared in this case? 5 minus 3 gives you 2. There's your answer. If you feel like you still don't know and you just need to multiply that out, you can. That would be the square root of 25, right? And then the next one would be the plus the square root of 15. The next one would be minus the square root of 15. And the last one would be minus the square root of 9. Well, obviously in here, these two would cancel out. And then I would get 5 minus 3, which is 2. Now, what's the square of the A? 4. And then subtract the square of the back number, which is 2. And so the answer is 2. Number 25. The square of the front number is 4 minus the square of the back number, which is I squared, which is negative 1. So this turns into a plus 1. So you get 5. Question is, what do you notice? No radicals. So that leads to rationalizing the denominator. We talked about rationalizing the denominator. I'm going to give you a minute and you can go ahead and do these for practice. You need to multiply by its conjugate. That gives you a hint. What is the form you need? You remember your form for radicals? What goes first? So make sure your answers are written in the correct form. to go. Let's go. Not going to be multiplied by what? Okay? That's the constant. That means when we square this, we go up 5 times 5. Square 5, that's 5, right? Minus 4. So on the bottom, we're going to get 1, right? But on the top, remember, you're still multiplying by 1 here. So now I got to multiply this right here and here. So that's going to give me 3 root 15. So 3 root 5 plus 6. Okay. That's 1, but I can't write it like that. It means you're written as 6 plus 3. That should be your final answer for number 26. Use that to help you with number 27 and number 28. Separate. Or it'll be so. So that's a good question. I like this. Peyton's got a great question here. He went ahead and multiplied by 3 minus root 6. 3 minus root 6. He found out this was 9 minus 6 gives him 3. On the top, when he distributed here, he got negative 6. And then positive 2 root 6. He says, hey, the 3 will go into 6, but it will not go into 2. This is where I call them, I say this is kind of like the triangle rule. If those 3 numbers are all divisible by the same number, then you can reduce all 3 at once. If not, you have to leave it the same. So this is one way of leaving it. And the other way, as I was showing Liam, is that you're going to divide each of these parts by 3. So that would give you like a negative 2 plus 2/3 root 6. Okay? So either one of these answers is acceptable. I will tell you that I want to make sure you know how to do both, because I'm not quite sure how the EOC would write it or the ACT. Okay? So they flip one. Okay? So they want to make sure you get that.
So it's going to 6 by 3.
Nope. But what's underneath, the only way you can divide into a radical is with another radical. So if you had root 6 over root 2, you can go into root 6. Okay? You cannot take a root 6 and divide it by 2. It's only 1/2. Okay? Get that last one there, Kate. So, yes. I'm seeing some good work on the bottom there. You got the denominator. You just got to get the numerator. So all of these are multiplied by the what? So what are you going to multiply by? There you go. Yeah. It is weird because it's imaginary, but you guys know how to. I'm giving you skills that you can multiply. And the 29 is a doozy. Three times 3 is 9. I times I is I squared, a minus sign, which makes it a plus 1, so you get 10 in the denominator. Numerator. 6, 2i, 3i, plus I squared. What do you know about plus I squared? Minus 1 plus the 6 is 5. Put these together. Anything special? Triangle rules, in fact, right? In this case here, we can divide everything by 5. So you get 1 plus. Didn't work. Go to the bathroom. All right. There's your final answer. Or you can write it as 1/2 plus I halves. So what you got, Kevin? Good job. Colton's on it too. All right, volume of a sphere. Anybody know the volume of a sphere? 216 here. 216 is going to equal the volume of a sphere. Your volume of a sphere is... Wrong. Yes. 4 pi r cubed. 4 pi r squared is your surface area. If I'm talking about volume, it is cubed. Okay, so we have r cubed. You may remember the one with the r cubed. What do we always have involved in there? Pi, and it's 4/3. All right. So 4/3 pi r cubed is your volume formula. Now we're trying to find the what? So there's a little bit of challenge here. Yeah, this is all multiplication, correct? So I need the r by itself. We're going to isolate the r. So what do we got to do first? No calculator needed in this case. There really isn't. Multiply by 3. Divide by 4. So you're going to multiply by the reciprocal here. Your multiplicative inverse of 4/3 is 3/4. So you're going to get that. How many times will 4 go into 216? Well, how many times will 4 go into 21? 5 times, giving you 20, right? Subtract. Bring the 1 down. Bring the 6 down. How many times will 4 times? So 4 times 54. So that makes it 3 times 54. Do not need to multiply it together. You really just need to simplify it. Now what? We got to get rid of over here, Kate. Yeah. Divide it by pi. That will wipe this pi out over here. All right, so how do you get rid of a cube? Cube root. There's outage worldwide. Yeah, since the internet's not working, we can't do anything. All right. My life is over. All right, cube root. Cube root. That will make this an R on one side. And on the other side, we're going to take the cube root of all of this. So the cube root of 3 times 54. You even know what 54 breaks down to? 9 times 6, which is 3 times 3 times 3 times 2. Is that right? Second. All right. So, looking like I have to remove this pi off the bottom. So how many more pies do I need down here? 2 more. Put pi squared up here, right? So let's rewrite this with all the triples out. So there's a triple of pi's on the bottom, so that's out. There is a triple of 3's on the top, which will be yanked out, leaving me the cube root of what's left over. 2 times 3 is 6 pi squared. Look, no calculator needed. Now, that is an exact answer. Remember, pi is an irrational number, okay, and it goes on forever. So this gives you the actual precise calculation. All right. No, I'm not familiar with the digits. All right, now, note set 2. Grab your calculator. This is time for your calculator. Knox has got his already out, so he was trying to calculate. He was trying to calculate pi. Yeah. I've got someone that's got back here next to Archie. Oh no. Fatal error. User error. It's a total user error. Constantly this one. So use your calculator and go ahead and find the values of all of these. Some of them you might see a pattern, you can do them pretty quickly. Others you will not. Yeah, there's a cable in the back, probably in on the floor over there that your calculator should fit to. Just take your calculator back here for you. Did it come up to 8? Or 16. Then you or 16. All right, now, guys, you will probably see within the pattern, remember, this is 16 caret symbol, parentheses, 1 divided by 2, like that, or 16 caret symbol, 0.5, okay? Some of these you're going to find out pretty quickly what they are. They are going to become more, they're going to become different down here, these down here. I don't know if you can calculate this, okay? But you can with your calculator, so go ahead and calculate those. We'll talk about them here in just a second. And then some of them are like real quick. Do what? Yes. You put parentheses. If you don't put parentheses, you're going to get 8. Go ahead and write your values down on all of those. Like I said, some of you are going to be really quick. Others will be a little more challenging. Yeah, all of those. 9 problems. Oh. But when you, well, if you're automatically puts it into that little power, like his, I'll show you, this is what I'll show. He's got the old operating system on his. Still. Have a swimming tonight. There's also a basketball game. You're there, aren't you?
But you should be done at 6:45.
I thought the boys' game started at 6.
You're not doing that.
It starts at 6:30.
The game's at 6:30. You don't have
No, I think they're going to be done at 8.
Yeah, probably. Maybe
It's definitely a typo.
we have to stay after school.
Yeah, I saw you.
No, yes.
Oh, today. Oh, wow.
I'm going to the doctor.
All right. Let's take a look here, guys. All right, so what do you guys get for this first one? 4, 11, right? And 9. So there's 2 ways you can look at this problem. I want you to take a look at both because they're both really important. Most of you guys are probably seeing this as what? The square root of 16. You can also look at it as 4 squared times 1/2. Okay? And what happens here is you get 4, 2 over 2, which is really just 4 to the first power. Okay? That is important as well to see it that way. So this one here would be 11 squared times 1/2 would make that 11. Right? So that's where this is 9 squared times 1/2. So that just gives you 9. It's also important to see it as a square root. Anything in square root. Same thing here. This is 7 to the third power times 1/3. Well, that would give me 7, 3 over 3, which is really just 7. But it is also 343 with a little 3 right here as your index. So I want you to understand that this little number down here at the bottom is your index here. Okay? So that's what that number. So if I had, like, I don't know, 100 raised to the 1/7 power, that would be the 7th root of 100. Okay? So you need to be able to see it that way. All right? So this one here, you end up with 9. This one here, you end up with 8. Now, you get down here, a little bit different, isn't it? Now, this one is, if you just follow suit, that is the cube root of 27 squared. Okay, now you can write it like that, or you can square 27 first. Most people take the cube root of 27, which is 3, and you square it, so it's 9. See that, Kate? Let me raise it up here so you can see it now. Does that make sense? Now, so the other way of looking at that is 3 to the third power times 2/3. So what happens to your 3's? They will cancel, giving me 3 squared, which is 9. Okay? It's really important to be able to see that as well as this. They will both be used in different circumstances, all right? So, again, 64 can be written as what times what? You can do 8 squared, right? And then it's 3 halves here. You can cancel out the 2's, and that would give me 8 to the 3rd power, which you guys know is 512. Now, the other way of doing that is doing 64. You take the square root of 64. You raise it to the 3rd power. Square root of 64 is 8 to the 3rd power, which is still 512. See that, Peyton? There's 2 different ways to look at this. All right, 16. 16 is 2 to the 4th power. That is equal to 16. So this could be written as 2 to the 4th, 3 to the 4th. So the 4's cancel out, and so I get what? 2 to the 3rd. So my answer is 8. So I'm going to take the 4th root of 16, and I'm going to cube it. Well, if you don't have an idea, that's 4 times 4, right? That's 2, 2, 2, 2. There is a 2 that comes out, and then you're going to cube it. That's how you get 8. Questions? You need to be able to see both of those. Now, the second section here is these are rational exponents. So the exponents here are written as fractions and numerators. So we want to write these as radicals. We just did that. The cube root here. So the key on all of these guys is that you're writing these as the denominator is your index. Oops. Now this one here, slightly different. Remember, you're going to put a square around this. Okay? You're going to put a cube around this. You're going to put a cube around this. Okay? You can put the cube underneath, but I say on the outside probably is more powerful and will be used. All right? You will be rewriting these as radicals. Okay? There is going to be a section where it says, hey, write this as a radical. You don't have to do anything other than write it as a radical. Okay? So, for instance, if I have, I don't know, a triangle to the A over B, to write that as a radical, it would be what? Okay? So that is the way all of those work. Okay? That is really basic. Okay? So that was the first part of this. So I want to get to the next part. Anybody have any questions over these? It should be kind of simple. It's really just the beginning steps of rational exponents. Okay? So we're going to do these 5 problems right here. So it says write into exponential form. So we're going to get rid of the radical. So in this case here, this would be, I'm going to take a stab at it. Colton, you got it? No? Write your x down. Over what? Mm-hmm. And what would that end up being? Yep. X squared n, I guess. It is x to the 2n. Good job. The next one. Anybody got this one? What's your index in this one, guys? 2. That's on the bottom. What goes on top? Draw them in. So it's x to the 6n. Where's that 2 coming from? That 2, right there. Whatever your index is. This number is a 3. That is your 3. The denominator is that little index, is your denominator. So what's your denominator for this one? So I'm going to have 4n. So on top is 16n, and then the x up here, and what does that turn into? All right, so that's x to the 4th. Now, if you got x to the 4th, that's good. The higher math you go, there's one little clause that we'll have to put here. You see that n is on the bottom here. x is not allowed to equal 0. That will be a clause you'll add in later in pre-cal. Okay, so we may talk about it at the end of the year after our final exam, our state exam in here in May or April. We may do this unit and we'll talk about that. All right, now this one here. What anybody got this one? All right, so this was the answer. Let me show you the step. This is the way I envision it in my head. This is the way I'm doing it in my head, okay? You're taking your number there, Murray, and that is a 1/2 power on 25, which we know is 5, right? And then you do the 1/2 power on the x to the 8n, and that's how I'm getting the 4n, okay? So if I'm doing that one, I'm going to get 32 to the what? What's your index on this one? 5. So I'm going to go put 5 on the bottom. What's on the top? 1. Okay. Then I'm going to do x 40m divided by 5. And I'm going to do y 10m divided by 5. I'm going to distribute this right here, guys. This is like 32 x to the 4m y to the 10n raised to the 1/5 power. These are equivalent statements, and all I'm doing here is I'm distributing that 1/5 to everything. Okay? Now, 32. Does anybody know what 32 is? This is one you need to have memorized. If you don't have it memorized, just so you guys know, if I went 2 times 2 times 2 times 2 times 2, if I write down 2 to the 5th power, that is 32. Okay? This is one you need to have memorized. 2 to the 5th is 32. One way to remember this there, Colton, there's when I add 3 and 5 together, 3 and 2 together, I get 5. So that's 2 to the 5th. All right. So if this is 2 to the 5th times 1/5, what would you get there? I am taking the 5th root of 5 2's. There's one group of 5 2's. So just a 2 will come out. So I wrote it like this, Colton, as 2 to the 5th. These 5's are going to cancel, give me 2 to the 1st. It's just, then that's going to turn into what? What's this one going to turn into? 8m. And this one? That is your final answer for the last one. As I showed you earlier, I did a triangle and an A and B. This is the meaning of that, okay? And we will stop there today, okay? So the rest of the time you have is to work on your homework. Please do your homework. Don't make this social hour. A block decided to take me off and they put everything away. They didn't even start in their homework or anything. So, the calculator? I don't think so. I think you're good.